All right, yesterday we talked about what methods? We talked about okay, solving quadratic equation. We first talked about the square root method. Only works for binomials with a single variable. Usually like this. That's the first one we talked about. The next thing we talked about was factoring. Actually, come to think of it, there are three types of equations we can use for factoring. When a is equal to 1, when a is not equal to 1. The third one we didn't talk about yesterday, but does exist, is when you have a binomial equation and both terms have variables. Because the square root method works for this type. You have two terms, only one of them has a variable and it's squared. But what if you have an equation like this? It's a binomial, but both terms have an x. The reason it's under factoring, because since they both have x's, you can factor out what they have in common. And now set both of these equal to 0 and solve. We didn't talk about this yesterday, but that's another form. If it was a perfect world, those would be all we needed. But not all equations are factorable. Or they may be, it's just that the factors are not integers. They could be rationals, they could be radicals, they could be imaginary. So then we looked at the third type, which was completing the square. And that's a whole process in itself. It's a mechanical process. And then we ended up talking about the quadratic formula. Which always works. The complete the square and the quadratic formula always work. It's just that the quadratic formula is a lot easier because all it is plug and play. The quadratic formula, does anybody remember it without looking at your notes? Very good. That's the formula. Very good. Very good. Or remember, now the only x you have is what you're solving for. There is no x there. It's only the coefficients. Because in your equation, you have A, B, and C there. So whenever you use the quadratic formula, you're always solving for the middle variable. Does anybody remember the complete the square method? It's a whole process. It's not just one formula thing. It's an entire process. Yeah, 6, 7 steps. Because you have to move the constant over, divide by b over 2 squared, simplify, square root, so it's a whole process. Again, watch the video. We did this is what took us entire day yesterday, just doing these. And we got one example of this one done. So let's begin again from the quadratic formula. Or do you guys want to do another complete the square one? Was that?
I think that was the part.
The complete the square? Yes, because that one requires more moving and you have to know all the algebra skills. If you have fractions, it's even now adds in a whole set of skills. But yeah, this one always works. This one is just plug and play. When you have an equation, the first thing you do is label your A, B, and C and plug them in there.
And it'll give you the same answers.
All of these will give you the same answer. All of these, the factoring, the complete the square, and everything will give you the same answer. Actually, that's what we can do. We could look at a simple equation and look at all three of those methods, and they'll give you the same answer. That's what we'll do. X squared plus 3x minus 10. So the first method we're going to look at is factoring. So we have, you have to set it equal to 0 because what are we looking for? Why does it have to be set equal to 0 to solve for solutions?
You're finding this.
Yes, you're finding the x-intercept. Solutions are x-intercepts. How do you find the x-intercept? We did this in chapter 1. Set y equal to 0 and solve for x. So remember, this is the same thing as y. So we set that equal to 0. And anything we have left are going to be our x-intercepts. Very good. So with factoring, remember, it doesn't always work. Because what if you have an imaginary number? There's no way you can find the factors. So this one only works if it's easy. What's first step? What goes in the first space? So in other words, what makes up x squared? X and x. This is important because what you put here is actually the same thing as in the middle. Because we're going to do examples where it looks like this, but it's not really this format. But that's what goes in the first spaces. Second step. Look at the second sign. If the second sign's a minus, what does that tell us? The signs have to be opposite. Why do they have to be opposite? We're right, because the only way this number here comes from this number times this number. And the only way it can be negative is if they're opposite signs. So one of them is going to be positive, one of them is going to be negative, when the second one's a minus. Since they're different signs, how do we know where the bigger number goes? You look at the first sign. The first sign tells us the bigger number gets that sign. So we know that this one's going to be the bigger number. Fourth step, we got to look at this number, this sign, and that number. We got to figure out what two numbers multiply to give you 10. And then because it's a minus, what two numbers subtracted give you the middle number. So what two numbers is it? Yeah, 5 times 2 is 10. 5 minus 2 is 3. So since 5 is bigger, it goes where the plus is. Sixth step. What's my next step? Or are we finished? Very good. What property is that called? The zero product principle. We have these two numbers here and here. They're numbers, and they have to equal 0. How can they be 0? So we take both of these, set them equal to 0. And those are our supposed answers. That's the factory. And actually, I'll go ahead and do another one with a non-leading coefficient of 1. Okay, really what we should do here is always check your answers before you go any further. There's a couple ways we can check this. One way, from here, if we took x plus 5, x minus 2, and if we multiply them together, what happens? Let's see. X times x is x squared. Positive times negative is negative. X times 2 is 2x. Positive times negative. No, positive times positive is positive. 5 times x is 5x. Positive times negative is negative. 5 times 2 is 10. Combine like terms. 5 is bigger than 2, so it's positive. 5 minus 2 is 3. This should be the same as what you started off with. That's one check. Another check is if these are your answers and I plug them into here, what should they equal? Yeah, if I plug these, I put them back in here, they should equal 0. Let's see. So we check them. Let's put -5 in there. So we have -5 squared, 3 times -5 minus 10. What is -5 squared? Positive 25. Positive times negative is negative. 3 times 5 is 15 minus 10. So it's 25. Since these are both negative, 15, negative 10. They're both negative. What do I do with the numbers? If they're the same signs, what do I do? Add them. 15 plus 10 is, so 25 minus 25 is 0. Check, that works. Same thing over here. Use our original formula. So anywhere you see an x, you put a 2. 2 squared plus 3 times 2 minus 10. 2 squared is 3 times 2, 6 plus 4. Those are your checks. Always, always, always check. Because I'm not saying that you do it wrong, but you could have somewhere along the way miswrote a number, forgot a sign. Or I've proven during the semester, I meant to write a 6, I put a 3 or something. It happens. So always check your answers. Let me see here. I had one. So if I had, we did this one yesterday, 8x minus 22x plus 15. Okay, we're still using factoring method. But the problem here, the leading coefficient is no longer 1. If it's no longer 1, what do? We put that in both of these first spaces with the x's. We'll get rid of them later on, but let's not worry about it. A lot of teachers in high school will teach you, find the factors of 8, find the factors of 15, and see which ones work. No, that's going to waste your time. This will be 5 steps and you're done, always. So we did the first one. Whatever's here goes in both spaces, x and x. What about this? Always second step is signs. What's the sign? What are the signs here? So always look at the second sign. If it's a positive, that means what? The only way this one could be positive is if the signs are the same. And again, that's where the first sign comes in. In this case, they're both minuses. Third step, take the first term and the last term and multiply them together. So 8 times 15 is 120. Now we got to find what times what equals 120. Since this is a plus, when you add them, it equals 22. That's the same as we did last method. So what two numbers multiply together to give you 120? Since it ends in a 0, we know 10's in there. So 10 times 12 is 120. 10 plus 12 equals 22. So we're pretty lucky there. And since they're both the same signs, it doesn't matter where they go. So I'll put 10 here and 12 here. Ten times 12, 10 plus 12. So far, so good. Now we factor. What do these have in common? It's not negatives. The only time we worry about negatives is if the first sign is negative. That's the only time we worry about negatives. So what number do they both have in common? 2. So I can factor out a 2. when I factor out of 2, I divide both of these by 2 to see what was in the parentheses. 8 divided by 2 is 4. 10 divided by 2 is 5. What about here? What's the biggest number that goes together here? Yeah, they both have a 4 in common. So I divide both of these by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. Whatever, at this stage, whatever I factored out, I just erase it, get rid of it. Because remember, the first term has to be 8. Where does this number come from? It comes from this times this. 4 times 2 is x times x is x squared. Check, that works. How about here? This last number is made up of this times this. Negative times negative is a positive. 5 times 3 is 15. Those are good checks. This middle number, it comes from this times this plus this times that. 4 times 3 is what? Well, 5 times 2 is 10 plus 12 is 22. That's how you check it. Last step, the 5th step is what? Set them equal to 0. 4x minus 5 equals 0. 2x minus 3 equals 0. Move the constant over first, so we add 5 to both sides. So we have 4x equals 5. And divide by 4. Again, it's all order of operations. It's all order of operations. And then same thing here. Add 3 first. And then divide by 2. And yes, you got to check those as well, which I'm not going to do because it's going to take too much time. That you can do on your own. Again, you should know if an answer is right or wrong way before you hit enter on your computer. You should never, ever be surprised you got an answer wrong. Unless you're too lazy to check it. And you deserve what you get. So always check your answers, because if these don't work, try it again. All right, so that's factoring. Okay, let's go back to this equation. Let's look at the next method, which was complete the square. So we have x squared plus 3x minus 10 equals 0. From your notes yesterday, the first step is what? Right. So you have to have all the x's to one side and all numbers to the other side. So in this case, we add 10 to both sides. So we have x squared plus 3x equals 10. That's first step. Move the constant term over. Second step. You have to make sure that this is a 1. It's important that in the complete the square, the leading coefficient has to be 1. If that's not a 1, you divide everybody by whatever that is. Okay, we're lucky because that is 1. So if that was a 3, we'd divide everybody by 3. So that's a 1. So my next step is what? Add b over 2 squared. It's a parenthesis, b over 2 squared. That's important. If you put b squared over 2, you're going to mess it up. So it has to be in parentheses, b over 2 squared. What's b in our equation? Right. B is whatever's in front of the x. So we add 3 over 2 squared to both sides. Again, the procedures are on the video from yesterday. You can watch that. On the left side, only do what's inside the parentheses if you can simplify it. Right side, work it all the way out. So I can't go anything here, so that side's done. So I have x squared plus 3x plus 3 over 2. Now this side, I got to work it out. So 3 over 2 squared means that both the top and the bottom get squared. So it becomes 9 over 4. 3 squared, 2 squared. They're both fractions. So what's the rule about adding fractions? What do you need? You need the LCD. But easy way to add or subtract fractions is with the butterfly method. So in this antenna, you multiply these. 10 times 4 is 40. And you multiply these. 9 times 1 is 9. And this operation is there. So on top, we have 40 plus 9. On the bottom, you multiply. 4 times 1 is 4, so you get 4. So this becomes 49 over 4. So whenever you add or subtract fractions, you can use the butterfly method. All right, now what do we do? Now we have to complete the square. On the left-hand side, whatever is under the square goes inside the parenthesis and the first sign. So it's x plus 3 over 2. We've completed the square. Because now at this stage, if we wanted to, if we move the 49 over 4 to the other side, we'd get x plus 3 over 2 squared minus 49 over 4. What do these numbers tell us? We talked about this yesterday. What do these numbers tell us? The vertex. That's called the vertex form. So inside the parentheses, it's opposite. So it's negative 3 over 2. And the outside, it is what it is. So it's negative 49 over 4. There's your vertex. That's the lowest or highest point of your graph. We talked about this yesterday. And if you look surprised today, That's because you didn't listen or bother your notes. But that's if we're trying to graph it. You do this to graph. We're trying to solve for x. We're trying to find the x-intercepts. How do we do that? We're solving for x now. So solve for x. How do we do that? To get to x, what do we have to get rid of first? We're trying to get to x. Think of it like a video game. It's Decided Fortress. What do we have to get rid of first? The what? Yep. We have to get rid of the exponent. How? Square root. We have to do that to both sides. But remember, whenever you square root something that's squared, what do we have to do? We have to put a plus or minus in front of here. Again, the reason why is in the video yesterday. So the square root and the square cancel. So we have x plus 3 over 2 equals plus or minus. With this side, remember the right-hand side we have to work all the way out. So we can split these up. We have square root of 49 over square root of 4. What is the square root of 49? And square root of 4? What's my next step? Move the 3 over 2 to the other side. We're solving for x. So we have to subtract 3 over 2 from both sides. So we have x equals negative 3 over 2 plus or minus 7 over 2. Since they both have a 2 on the denominator, we're good to go. We just have to worry about the top. So it's negative 3 plus or minus 7. So from this point, we have to do 2 equations because of the plus or minus. We have negative 3 plus 7 over 2 and negative 3 minus 7 over 2. So what is negative 3 plus 7? Since they're opposite signs, the answer is going to be what? Positive or negative? Why? Because 7 is bigger than 3. So the answer is positive. 7 minus 3 is 4. 4 over 2 is 2. That's my first answer. Then we have negative 3 minus 7. They're both negative. Add the numbers. So negative 10 over 2 is negative 5. Those are my answers. And it's the same answers we got last time, so we know it works. But you see, it's very labor intensive. But it's always going to work. It's going to give you an answer. Whether it's imaginary or not, it doesn't matter. It's going to give you an answer. And the last one method we're going to use is the quadratic formula. The same equation. So we have x squared plus 3x minus 10. First thing you do is label A, B, and C. So what's A? Positive 1. What's B? Positive 3. What's C? Negative 10. For those of you who don't know, quadratic equations have this form. A, B, and C are simply the coefficients, and the signs go with them. Since we're using a quadratic formula, we now have to put down the formula. Negative b plus or minus b squared minus 4ac over 2a. It's just a matter of plugging and playing now. So we have the negative. What is b? It's 3 plus or minus b, which is 3 squared. 4 times a, which is 1. C is negative 10 over 2a, which is 1. The hardest thing about this process is you have to know how to do your algebra in the order of operations. So according to order of operations, we have to do inside the parentheses, or the radical. Exponents first. So 3 squared is 9. And we do that part. Negative times positive times negative is what? Positive. Basically, count the number of negatives. If it's an even number, it's going to be positive. Negative times negative cancel out. 4 times 1 is times 10 over 2 times 1. And continue the process. Inside the radical, 40 plus 9 is 49. Square root of 49 is 7 over 2. So here's we have positive 7 and negative 7. So x is equal to negative 3 plus 7 over 2. X is equal to negative 3 minus 7 over 2. Seven minus 3 is 4 over 2 equals 2. So x equals 2. They're both negative. Add the numbers. So x is equal to negative 5. Those are all 4 methods we talked about yesterday. Now, again, typically people, whenever they're asked to solve for quadratic equations, they jump straight to the quadratic formula. It even works if you're dealing with binomials. It even works if it's deal with binomials. I mean, hopefully from here you can do the rest. It's just algebra, basic math. Let's say we had 2x squared plus 4x equals 0. Typically, if you saw this, you would use the factor method because they both have a what in common? They both have a 2, and what else? They have an x. So if I divide both of these by 2x, what am I left with? So the 2's cancel, 1x cancels, so I'm left with x. 4 divided by 2 is 2, and the x cancels. So now I set both of these equals 0. Whenever you factor, whenever you have an x and you're solving, set that equal to 0. Just because there's no parenthesis doesn't mean you don't have to solve for it. Because what it says here, if we divide by 2, x equals 0 is a solution. If x equals 0, what's y going to equal? What's this one? If x is 0, what's this going to equal? 0. If x is 0, what's this going to equal? 0. So do not forget to set this one set equals 0 and solve for it. Then this side here, x becomes -2. There's another solution. So let's use the same equation and let's use the quadratic formula. To use the quadratic formula, what do we have to do first? We have to label A, B, and C. Well, first off, make sure it equals 0 first. Because if it doesn't equal 0, your A, B, and C are not going to be real numbers. They're going to be wrong signs. So what's A? A is in front of the x squared. It's 2. What's B? It's in front of the x. It's a positive 4, so it's 4. What's C? There is no constant, so it's 0. I know you won't do it, but again, to minimize your chance of mistake, always start off writing the formula down. Don't start plugging in the numbers in the equation. Put it down first, and then start plugging stuff in. So what's B? There's the negative. B is 4. B is 4 squared. 4, A is 2, C is 0, over 2A, which is 2 times 2. So we have -4. 4 squared is 16 minus 4 times 2 times 0 over 2 times 2. That's you. So we have -4. 16 minus 0 is square root of 16 over 4. What's the square root of 16? is 4. So we have two possible answers. So it's -4 plus 4 over 4 and -4 minus 4 over 4. -4 plus 4 is 0. 0 over 4 is 0. So x equals 0 is my first answer. -4 and -4 is -8. Over 4 makes it -2. So x equals -2 is my next answer. We just said that's what the answer is supposed to be. So the quadratic formula works no matter what you have, as long as it's quadratic. Now, another cool thing about the quadratic equation, it's going to tell you how many solutions you're going to have. Remember from yesterday's lecture? What's the most and what's the least amount of answers I can have in a quadratic equation? Quadratic equation can look like this. I can have 2 solutions. I can have 1 solution, or I can have no real solutions. Because it doesn't cross the x-axis. Remember, the solution is the x-intercept. But using the quadratic formula, it can tell me how many answers I'm going to have before I start doing anything. Now, what causes this to have 2 answers? Well, no. Well, we know that, but what in this formula causes it to have 2 answers? The plus or minus. Notice this part right here. Right. This part here is very important. Because if that part's gone, how many answers are we going to get? Well, negative b over 2a, we only get 1 answer. And this is going to be important in a second. If this part here is gone, we just have negative b over 2a. And that gives us that answer there. So, why is this important? This is called the discriminant. Tells us the number of real solutions. So it's b squared minus 4ac. That's the discriminant. And so it can have 3 possible solutions or outcomes. So the discriminant tells us the number of real solutions we're going to have before we start doing anything. So we just take b squared minus 4ac. If that number is positive, then this is going to be a real number. So we're going to have, then we have 2 solutions. Because if what's inside the square root is positive, then we're going to get a real answer. If it equals 0, then we're going to have one solution. Because if it equals 0, it's gone. All we have left is negative b over 2a. And if it's negative, then we'll have no real solutions. Why is it no real solutions? Very good. If it's negative, it becomes what? Imaginary. We talked about that. If we have inside the square root, if we have -4 or a negative number, this negative makes it imaginary. And we can't graph it. So that's what the discriminant tells us. It tells us before we go any further, how many solutions are we going to end up with? So far, so good? I know we have a lot of things to learn, but it's all building on itself. So equations that are quadratic in form. More so but a general term is equations that are quadratic in form. All right. We know so far that we've been dealing with, we have that. That's our quadratic equation. How many solutions are we going to come up with? Maximum. How many solutions? Anybody? 2, because it's quadratic. And we can use the quadratic formula and everything like that. When you use the quadratic formula, you solve for x, which is the middle term. Now, what makes this quadratic in form? Look at the exponents. What's this exponent? 1. What is this exponent? So it's how do I go from here to that? What do I do? How do I go from 1 to get to 2? Mathematically, what do you do in multiplication? If I multiply by 2, 1 times 2 is 2. The reason I'm saying that is because is this quadratic in form? Yes, because the same reasoning. If I take this number and if I multiply it by 2, what do I get? 4. So I can use the same rules of quadratic equations for this one that I did in the other ones. How many answers are we going to have? We're going to have 4 answers. That's never going to change. The leading coefficients, the degree is always going to tell us how many answers. But now we have a simpler way of solving this one. Find me the x-intercepts of this equation. This is example 7. So what do you think we're going to use here? Can we use factoring? Well, let's see. If we use factoring, it has to be set equal to 0. So what term goes here? Remember, no. Remember, I just told you a second ago, which term do we look at that we're solving for? The middle term. Watch this video over. I told you 3 times. You always solve for the middle term. So x squared, x squared. What are the signs going to tell me? The second sign's a plus. So what does that tell me? The signs are the same. They're going to be what? They're going to be minus. This is where, remember the 2 different methods? It's not really different. We use the same logic here. What's the coefficient here in this first one? If I take the first term and multiply it to the second one, 1 times 4, I get 4. It's the same thing we do if this was a 3, it's the same thing. So it's the same logic. So now we got to figure out what times what equals 4, because that's a plus. When I add them, I have to come up with a 5. What's that?
We're gonna come up with a negative one.
Nope. You're overthinking. 4 and 1. 4 times 1 is 4. 4 plus 1 is 5. So I put 4 and 1 in here. I set both of these equal to 0. And I'm going to show you another one. We have methods for factoring these as well. But it's only 2 terms. I could add 4 to both sides. So I have x squared equals 4 and x squared equals 1. Then what? Square root, because you're solving for x. So we have x is equal to what? Plus or minus 2. Remember, you have, whenever you take a square root of something squared, you have to put a plus or minus in front of it. Same thing on this side. So x is equal to plus or minus 1. These are my 4 answers. X equals 2, negative 2, 1, negative 1. Those are my 4 answers. Everybody okay with that? It's that beep value.
That doesn't matter if it's a negative in front of it.
Because they're both the same signs. They're both both of these numbers are negatives. So -4 plus -1 is -5. That's why signs are no longer that important once we factor them out. And you do the same thing for the quadratic equation. But the quadratic equation what's A? What's B? And what's C? What's A? What's B? -5. And what's C? 4. When you label them, the signs go with the numbers. So in the quadratic formula, what are you solving for? What do you look for in this equation? The middle term. So that's what you're solving for. I said 4 times now, 5 times now, that whenever you're solving quadratic equations, you're always solving for the middle variable. So there's the negative. What is B? B is -5. -5 squared minus 4 times 1 times 4 over 2 times 1. Plug and play. So a negative makes it a +5. -5 squared is 25. The negative times positive is a negative. 4 times 1 times 4 is 16. Again, all this stuff here, you guys should be able to do. It's just math, basic math. -25 minus 16 is 9. What's the square root of 9? 5 plus or minus 3 over 2. Square root of 9 is 3. So we do a +3 here and a -3 there. 5 plus 3 over 2. 5 minus 3 over 2. 5 plus 3 is 8. Over 2 is 4. So x squared equals 4. 5 minus 3 is 2. Over 2 is 1. So x squared equals 1. And do the same thing we just did. So x is equal to plus or minus 2. X is equal to plus or minus 1. Any questions so far? We will do one word problem. Look at example 11 on your last page of the packets. Yes, there was. Who didn't bother looking at the table on the way out yesterday? or on the way in. Go get him. No, come and get it. Come get it. It's the on section 3, chapter 3, section 2. It's the last page. This one says train speeds. 2 trains leave a station at the same time. One traveling due west and one traveling due south. So one going due west and one going south. The train traveling west is 20 kilometers an hour faster than the train leaving go south. After 2 hours, the trains are 200 kilometers apart. So, what does it mean when they're 200 kilometers apart? It was right to the picture. From where? What am I looking at? From where to where? Which point? You're right. But I don't see if you're defining the same thing I'm looking at. What's that? What part of the lines? What part of the lines are we talking about? You're saying south and west. You're saying points on the line. I don't know where these. Where on this graph am I looking at for 200 miles apart? What's that? Dang. From this point to this point is 200 miles apart. Kilometers. So you have to be specific. It's from the end of their travels, the end of their lines. Why is that important? Because they said they travel after 2 hours. They're 200 kilometers apart. So what formula are we going to use here? What's that? Do we get is it quadratic just yet? We have to set it up first. How do we set it up? What formula do we know that describes this picture? It started the circle, but what's it called? No. What's that? Pythagorean theorem. Very good. This is x, this is y. Let's call this z, or d. So it's x squared plus y squared equals d squared. So we're looking at distance. What's the formula for distance? Rate times time. How fast you're traveling for how long? So we have 2 trains, the one going westbound and the one going south. What do we know about this one? How do we put that? Y plus, no, we're gonna use R and T here. So yeah, one of them is gonna be R plus 20. The other is gonna be R. Which one's which? Times the time plus RT. Remember, these are squared. So what's my D? $200, and it's squared. So it says after 2 hours. After 2 hours. So how do I do that? Where's that go? Yeah, so T is equal to 2 hours. It's the same for both trains. So we have 2 times R plus 20 squared plus 2R. Now comes the hard part. We have to take this and distribute it. So we have 2 squared R plus 20 squared plus 2 squared R squared equals 200 squared. So far, so good. 2 squared is 4. 2 squared is 4. What's 200 squared? It's easy because it says it has zeros. So we squared. 2 squared is 4. Now, what it means is 200 times 200. So we're going to have 4 zeros after that. So whenever you have zeros, just square the number and then take 2 of those and then 2 more of those since they happen twice. So far, so good. We're still setting it up. This is the problem here. What do we do with the R plus 20 squared? What do we do with that one? You cannot distribute. What this means is this. So we have to distribute. Okay, did you mean distribute the R in there or R plus 20, R plus 20? Yeah, so you cannot do that. What this says is it means R plus 20, R plus 20. So R times R is R squared plus R times 20 is 20R plus 20R. And 20 times 20 is what? 2 times 2 is 4 and 2 zeros. So it becomes R squared plus 40R plus 400. Yeah, that's this r plus 20 squared. So this goes in place there. So it's 4 times r squared plus 40r plus 400 plus 4r squared equals 40,000. Distribute. So we have 4r squared. 4 times 4 is 16 with a 0 behind it. 4 times 4 is 16 with 2 zeros. Combine like terms, we have 4r squared makes it 8r squared plus 160r plus 1600 equals 40,000. Fortunately for us, we can notice one thing about all these numbers. What do they all have in common? 8. So if we divided everybody by 8, so we get r squared. 16 divided by 8 is 2, so it's 20r. 16 divided by 8 is 2, 200. 8 goes into 40 5 times, so it becomes 5,000. What do we have to do next for our equation? Has to be what will we do first? Right. Has to be set equal to 0. So we subtract 5,000 from both sides. Because it has to be equal to 0. So we have r squared, 20r. Since 5,000 is bigger, it's negative. 5,000 minus 200 is 4,800. So we have r squared plus 20 r minus 4,800 equals 0.
So going down, we're going to front those two.
Well, that's what we'll find out. No, because that's the is once we find r, we have to see if it's legitimate. Because then for one, we just add 20 to it. But it's the same r. R is for the slower train. So what signs go there? Because it's a minus, they're opposite signs. And the bigger number goes where? Because that's positive. Now we got to figure out what times what is 4,800. When you subtract them, you get 20. So basically, we're lucky because these end in zeros. So what times what's 48? When you subtract them, you get 2. What times what equals 48? When you subtract them, you get 2. Actually, five. There you go. Take one, pass it around. These are little multiplication cheat sheets for y'all to help you do your multiplications. So what times what is 48? 8 times 6. 8 minus 6 is 2. So it's 80 and 60. Plus 0 times 0 is 0, 0. So set these equal to 0. R equals negative 80 and R equals 60. So what do we know? Which one cannot be true? You can't have a rate of negative 80. So the rate that we're dealing with is 60 miles per hour, kilometers per hour, whatever the units were. So that's the speed. Remember, so the first one is 20 kilometers per hour faster. So this one is going 60 and this one's going 80. That's what it means. Oh, we have time to start. All right. That's it for that section.